Okay, so let's have a look at the effect of mass and volume when dissolving together. So we'll start with mass then. So when a solute is dissolved into a solvent, mass is conserved. Okay, now conserved is a lovely key word, and what that actually means is that the total mass of the products is equal to the total mass of the reactants. So above, I've got a nice sort of simple example to show you. So we've got like blue copper sulfate over here added to a colourless beaker of water, and then we're going to make a blue copper sulfate solution over here. It doesn't actually matter what it is, but it's key to note that these are our reactants, the things at the beginning of the reaction, and this is our product, the thing that we make in our reaction. Now, the mass of the reactants has to be the same as the mass of the products. So the mass on the sort of the left-hand side of the arrow and the mass on the right-hand side of the arrow have to be the same. So in this example here, you've got 5 grams of copper sulfate added to 150 grams of water. Well, those two things added together is 155 grams. And we've got 155 grams of our product, okay? And that is what you would expect. You'd expect the mass to be the same, or the mass to be conserved. So in the video that you looked at and the questions that you were doing, it says calculate the mass of the beaker and the water and the weighing boat and the solute before dissolving. So in this example, you take the masses and add them together. And you do the same for after. So these are the results for that. So if for before dissolving, I've added 94.48 to 1.83, and I've got 96.31 grams. That's before dissolving. Then after dissolving, I've got 95.9 grams and 0.39 grams, which gives me 96.29 grams. Now the third question says, therefore, how does mass change during dissolving? Now, essentially what that's saying is what has changed between this value and this value. And I see that some of you might be tempted to say that we have lost 0.02 grams. And I see that that is actually true. However, 0.02 grams is actually a very, very small amount. Very, very tiny mass that we've lost. And what's probably happened is when we have, I don't know, stirred it with a stirring rod, some of the water has stayed on the stirring rod and not all of it has come off. So actually that's where we've lost that mass. So don't think that this tiny loss in mass actually is a loss in mass over time. It's just human error. It's some error that has come into the experiment somewhere. So how does mass change during dissolving? Mass does not change. Oops. It is conserved. Okay, so it remains the same. Okay, so let's move on to the effect on volume during dissolving. So as a quick recap then, in obviously dissolving you have your solid solute and your liquid solvent. They're going to dissolve together to make the solution. So remember that particles inside of a liquid have small gaps in between them. Now remember that they're not massive gaps, they're not big enough to fit other particles inside, other liquid particles inside, but they are big enough to fit little small solute particles in between them. So during dissolving, what's happening is the liquid particles that can move are going to collide with the solid particles. That's going to give the solid particles a little bit of energy and help them to move through the liquid and dissolve through it. So we're breaking apart that big solid. Now what that means is these solute particles, as they move around the liquid, are going to fill those tiny gaps in between the liquid. So actually the volume overall does not increase. Okay, so volume stays exactly the same throughout dissolving. So some evidence for this can be seen in this YouTube link here. So I'll put this at the bottom of the Firefly page, so do have a look at this if you'd like to. It's quite a long video actually. At the Firefly page. And what this scientist has done is he takes 400 centimeters cubed of water and 400 centimeters cubed of salt in 2 measuring cylinders. Okay, he mixes them together. Now what you would expect to happen, if I've got 400 centimeters cubed of both of these two things, you'd expect the volume of the product to be 800 centimeters cubed. Okay. However, when we add them together, the final volume is only approximately 625 centimeters cubed. And what that means is that a lot of that salt, a lot of that solute has gone in between the particles of the liquid, which hasn't affected the volume. The reason the volume has increased overall is because we've saturated that solution so that the solid has sunk to the bottom and it has displaced the water up. Okay, so I asked you a couple of questions on the effect of volume, and I want to go through the answers with you now. So question 1 says, explain why there is no increase in volume when a solute is dissolved into a solvent. Okay, so the solid solute particles are broken up and fill the gaps between the liquid solvent particles. This results in no volume increase. That is true until we saturate the solution, of course. Question 2 then, a scientist has 21 grams of water which takes up 20 centimeters cubed. He dissolves 5 grams of copper sulfate crystals into the water. What would you predict his observations would be in terms of mass and volume? So let's have a look actually at volume first. Well, as we've just said, volume stays the same during dissolving. So the volume that we've got in the question is 20 centimeters cubed. We'll assume it doesn't saturate the solution. So the volume of the solution is going to be the same as the volume of the solvent. The mass then, so mass is conserved. So we have calculated that there is 21 grams of water and 5 grams of copper sulfate. We would add those two things together to make 26 grams of the solution.